This is one of the geological wonders of the world.
Let's see.
The Great Rift Valley. A breathtaking 6,500 kilometer depression in Africa, which has the East African Rift at its heart. It is so vast, it's visible even from space. On the surface, it truly is one of the most remarkable beauty spots on Earth. But the area hides a sinister secret deep below. This peaceful-looking paradise is actually one of the most violently active tectonic faults on Earth.
I mean, it's so hot there.
Beneath the feet of 120 million people, a colossal force is pulling at the very foundation of a continent.
What?
For more than 20 million years, a giant crack has been spreading down the east side of Africa, cutting through Ethiopia, Kenya and Tanzania, slowly but surely ripping Africa in two. I'm James Stewart and you're watching Astrum Earth. In this video, we'll explore the forces of nature behind this geological powerhouse.
Africa's about to crack.
Ask whether the second largest continent in the world really is tearing itself apart, and if so, what does that mean for Africa? What kinds of consequences can we expect from the biggest continental reshaping event since the breakup of Pangaea? If you were to peer into the Earth's crust in this part of the world, you'd find the African plate, which boasts the fourth largest tectonic boundary in the world, and that's just the major one. The African plate is further split into the Nubian plate to the west, which carries most of the African continent, and the smaller Somali plate to the east, which carries the Horn of Africa, the easternmost extension of African land. But this was not always the case. Until recently, geologists thought there was only one plate in Africa. It wasn't until the 1970s that Kevin Burke and John F. Dewey provided compelling evidence that the single plate model didn't fit, and that the African plate had actually been separated as far back as the Cretaceous period. These two plates pulling apart is what creates the East African Rift system. The more technical term for this battleground is a divergent plate boundary, as the Somalian tectonic plate and the larger Nubian tectonic plate move away from each other. To make matters worse, the Nubian and Somalian plates are also separating from the Arabian plate to the north. This has created a Y-shaped rifting system in the Afar region of Ethiopia, known as a triple junction. Further adding to concerns, a split may be inevitable. Central to the movement of these tectonic plates is the Earth's lithosphere, the layer of solid rock that makes up the lands that we walk on and the ocean floors we see today. As impressive as it sounds, it's very thin, and often compared relative to the skin of an apple. The lithosphere floats on top of the mantle, a layer of semi-solid rock that behaves like a thick, slow-flowing liquid. Heated by the core of our planet, which is as hot as the surface of the sun, the semi-solid rock rises toward the lithosphere, where it then flows outwards, cools, and sinks back down again. These thermal currents drag the continents around the surface of the planet in a process called continental drift. We have a whole video on lost continents if you want more on this. To keep things brief here, this was one of the main drivers behind the ancient supercontinent Gondwana breaking up 180 million years ago and splitting into the landmasses we recognise today: Africa, South America, Australia, Antarctica, the Indian subcontinent and the Arabian Peninsula. There is still some debate about whether Africa will split apart or not, but the leading theory as to how this could happen centres around an underlying superheated plume.
Well, it's going to take millions of years.
At Fern, you can see how the thermal current in the lithosphere, heated by the Earth's core, rose towards the surface, lifted and eventually cracked the supercontinent.
Is there going to be a volcano?
It then quite literally dragged Africa and South America apart, relieving the pressure that had built up, and allowing gravity to pull the two pieces back down and forming what is now the Atlantic Ocean. A similar process far more recently formed the Red Sea at the northern end of the East African Rift system. It was a geologically unstable valley surrounded by high mountains, pushed upwards from below until it reached breaking point. The valley above the fault gradually thinned and became weaker the more it was stretched. As the Arabian plate below separated from the Nubian plate, the stretched lithosphere above collapsed and gradually opened the Gulf of Aden and eventually the Red Sea. Discussions are ongoing as to whether the same thing is happening here in Africa, with the main hypothesis suggesting that rising thermal plumes within the Earth's mantle are causing an upward bulge and stretching of the lithosphere, comprising the crust and upper mantle beneath Kenya and Ethiopia. This lithospheric thinning has resulted in extensive outpouring of basalt lava, characterised by lava flows erupting from newly formed fissures, fracturing the brittle continental crust into a system of faults. In short, planet Earth, and indeed this region specifically, has a history of splitting apart, so you can see why this concern would stand to reason. So what would happen if it did split? Today, the rift remains above sea level, but if it continues to widen, the land within the valley will sink. Now, eventually this would allow water from the Indian Ocean to flood into the basin, creating a sixth ocean. Ken MacDonald, a marine geophysicist and professor at the University of California, said eventually this area would become its own small continent. The very makeup of planet Earth would look significantly different. The traditional shape of Africa that we all know would be almost unrecognisable. The future version of Google Maps, whatever that may be, would exhibit a large island with a new continent plonked in the Indian Ocean, consisting of parts of Ethiopia, Somalia, Kenya and Tanzania.
Are we even gonna be alive by that time?
Quite literally everything, from biodiversity to water resources and agricultural practices. Moreover, the gradual separation might influence the continent's geopolitical landscape too, as new maritime routes emerge and nations reassess their territorial boundaries.
No shot.
But how quickly could that happen? Well, at present, GPS measurements indicate that the Nubian and Somali plates are pulling apart from one another at an average rate of 7 millimeters per year, although estimates vary. For the Somali plate to completely break away and form a new ocean then, it would likely take tens of millions of years.
I will be dead by that
level,
time.
who's to say who might be around to feel the effects or see what the planet may look like? As daunting a prospect as it sounds, there may be some upsides too, and one in particular is something the world is currently crying out for. The main benefit of having an enormous upswelling of magma beneath your feet is access to a rich resource of geothermal energy. If it became more easily available, it could make several countries above this fault completely self-sufficient, energy-wise. Ethiopia and Kenya have already reached a geothermal power generation capacity of over 1,100 megawatts, and you'd imagine this number would multiply significantly. With the world actively looking for renewable energy resources to replace the burning of fossil fuels, the countries that span the East African Rift system could be sitting on an economic goldmine. Whilst there is still some debate about whether this will or won't happen, there has been some compelling evidence to back up the will argument. In September 2005, a huge crack did appear in Ethiopia's Afar region, seemingly overnight. Despite quite obviously looking like it should have been created by the fault opening, that doesn't appear to be the case. Instead, the crack opened when a volcano at the northern end of the rift called Dabahu erupted. The fissure exploded out of the side of the Dabahu volcano, which had been inactive in recorded history. The Dabahu volcano began to swell, followed by a swarm of 131 earthquakes. Then, on the 26th of September 2005,
I never heard
an
of it.
eruption blew out a vent of boulders
Oh, it was a
and
long
ash,
time ago.
leaving a crater 500 meters long
Whoa.
and 100 meters wide. Using sensor data, a team of researchers at Addis Ababa University in Ethiopia found that a 60-kilometer long, 8-meter wide dike of solidified magma formed in the rift, causing the crack in a matter of days. Okay, that explains that crack, but there was also one in 2018, this time in Kenya, where a 1-kilometer chasm opened up seemingly out of nowhere. Surely this is evidence enough of continental rift? Well, maybe, but it seems like the answer is actually much, much less dramatic. While the larger rifting system could be the underlying mechanism for the chasm, the sudden appearance was likely due to heavy rainfall in the area. The general consensus among geologists now is that the pre-existing crevice had remained undetected because it was packed with volcanic ash
it's
from
not that
eruptions
deep.
in the distant past. It was then suddenly exposed when the deep layers of ash collapsed and were washed away, leaving behind a giant scar in the ground. So it seems like Africa might not be splitting apart after all, and surely a continent not being ripped apart is good news, right? Well, in this case, I'm afraid not.
What is that?
You know what's got more cracks than an entire continent? My internet browsing history. Honestly, surfing the internet today
Is
is
this
like...
the end?
It's
This the end?
Get out. Great. The risk is in the video. In fact, Africa splitting apart might actually be the lesser of two evils.
What is
Let
that?
me explain. You see, it is also possible that the geological forces driving the rifting might prove too slow to eventually separate the Somalian and Nubian plates. Cynthia Ebinger, chair of geology at Tulane University in New Orleans and a science advisor to the United States, points out that failed rifts mark continental landmasses worldwide. She draws attention to the mid-continent rift in the very heart of North America, which curves for about 3,000 kilometers across the upper Midwest. Just over 1 billion years ago, the mid-continent rift system was once a similar divergent rift fault, a 3,000 kilometer long feature ready to split what is now North America into 3 pieces. It was powerful enough to create Lake Superior, and the enormous crack through the Earth's surface spread as far southwest as Kansas, and then nothing. It just stalled, fell silent.
It
A
fell
continent
asleep.
killer vanishing into the darkness. Over time, it has completely solidified and is now one of our best examples of a failed rift system.
What about Yellowstone, though?
One of the most noticeable features of the mid-continent rift system are its vast deposits of basalt, an igneous rock formed from huge outpourings of lava. Working almost like a geological glue, this basalt has helped to heal the rifting fault, holding it together for 1 billion years like Earth's self-healing bandages. The scale of this is difficult to
Looks like a
absorb.
mountain
Those
rushmore.
lava flows spread from Lake Superior across 6 American states. But why did this happen? And could it be a clue as to what's happening underneath Africa as we speak? As we talked about earlier, continental rifting occurs when magma below the surface is forced upwards and rips open the lithosphere. And this is what failed to happen in the American mid-continent rift system. The crack through the Earth's crust could not open for
Is this
some
a drone
reason
footage
that we
or a
do not
CGI?
yet understand.
It
So
looks-
instead of slowly pushing the fault
looks
apart,
crazy.
the magma, under enormous pressure from below, burst through the cracks and flowed out onto the surface.
Jeez.
It's been estimated that more than 2 billion cubic kilometers of lava erupted through the mid-continent rift, with individual flows exceeding 600 cubic kilometers, extending more than 40 kilometers across. Staggeringly, this was only one single eruption, and there were many eruptions, hundreds of thousands of eruptions, combining to form continuous lava flows. The area they covered was enormous, and they would have obliterated everything in their way. So if we apply that same event to Africa, if the East African rift system cannot spread sideways, that enormous pressure will have nowhere else to go but up. So actually, are those cracks the early warning signs of something much worse than a continent splitting? Are we looking at a failed rift which would create a disaster of global proportions?
Let's find out.
Before we get stuck into this, I do want to point out that while there are a lot of similarities between what happened a billion years ago in North America and the East African rift system, there are also some differences. So any predictions are just that, predictions. Much like a paleontologist piecing evidence together to envisage the creatures that once walked our planet, we can use the North American example to help create a well-informed potential scenario in Africa. Because we can't see what's happening below the magma layer, our knowledge comes from the analysis of lava flows that erupt at the surface, and from methods like seismology that can construct a picture of what's happening inside our planet from the way vibrations travel through it. From this information, and making comparisons with ancient rock formations, scientists can build models that best explain what they believe is happening beneath us. But we can't dig a hole and go down to find out how accurate these models are. Now, what these geological models indicate is that there is a superplume of hot magma rising underneath the East African rift system, as we've discussed. And incidentally, these same conditions prevail that existed at the early stages of the mid-continent rift system. No two faults are ever exactly the same, but it does raise the possibility that instead of Africa splitting apart, that magma plume could cause lava to flow out onto the surface, and the results of that happening would be catastrophic. If the East African rift system behaves in a similar way to the mid-continent rift system, what we can expect are effusive eruptions. Those are less violent but involve much more lava. The sort of lava flows to the ones we saw in North America would cover nearly half of Ethiopia, most of Kenya, and even extend into Uganda and Tanzania.
Whoa, why is
Here's
so
where it
big
gets
though?
really scary though. Because the East African rift system is not on the same scale as the mid-continent rift. It's 3 times bigger. There have been no effusive eruptions in human history that even compare to the size and scale of this. The eruption that comes closest and was the biggest in recent history was in Laki, Iceland, which started in 1783 and lasted 8 months.
What?
The haze caused by this eruption reached as far as Syria, caused crop failures, killed off much of Iceland's livestock, and sadly, a quarter of the population perished from the resulting famine. For comparison, this was from an eruption of a mere 14 cubic kilometers of lava. Just one single lava flow from the mid-continent rift exceeded 600 cubic kilometers.
I don't know.
In other words, if the East African rift system does follow the pattern of the mid-continent failed rift with large effusive eruptions, the consequences
What the hell do you even do in this type of
severe.
situation? You just leave? I mean, I guess.
Remember, this area is the largest seismically active rift system in the world. The Dabahu volcano in the Afar Triangle began to swell in 2005. There are 78 active volcanoes in the East African rift system.
Oh my god.
Monitoring
what?
of previously dormant volcanoes within this rift system
Can we throw a nuclear bomb there?
2008 did show
Just to see
signs
what's
of
gonna
deformation, the first indications of impending disaster. This growing volcanic activity and more frequent earthquakes of higher intensity were what began to raise speculation that the East African rift system
What? They got
is finally
earthquakes
on the
in
move
Africa?
in the first place. and they continue to increase rapidly.
Never knew that.
In 1977, Mount Nyiragongo on the western fault of the two main rifts erupted, emptying a lake of unusually liquid lava that flowed at speeds of 60 kilometers an hour, the fastest lava flow ever recorded.
Whoa.
It erupted again in 2002, partially destroying the city of Goma, and
It's
then
like
again in
average
2021.
Speed.
Following a long period of relative quiet, the Oldonyo Lengai in Tanzania has also been more active since 1983, and then in September 2007, it suddenly erupted in spectacular fashion. It vented out huge amounts of lava which continued well into 2008 before it settled down once again. Satellite monitoring has shown deformations around the volcano, suggesting more increased activity in the magma below. When volcanoes start to move and bulge, it tells us that the pressure of the underlying magma is increasing, and it's exactly this type of movement
That thing looks so
precedes
surreal.
eruptions. Something else to bear in mind here is the type of lava. The Oldonyo Lengai volcano in Tanzania is the only active volcano known to produce
We need to come up with some big ass fire extinguishers.
a unique type of lava known for
for
its
this type of
unusual
shit.
composition and
What
low
the
eruption
hell?
temperatures. Most lava that emerges at the Earth's surface is very hot, over 1,000 degrees Celsius, and soon solidifies at cooler temperatures. The lava produced by Oldonyo Lengai, however, is much different. It is high in alkali minerals in the form of carbonates and low in silicates. Without the usual chains of silica to give the magma structure, it remains liquid at much cooler temperatures, nearly 500 or 600 degrees Celsius. In volcano terms, it produces cold lava. This particular type of magma has about the same consistency as olive oil, allowing it to flow faster and further than other types of lava. And that may well be a crucial factor.
Oh, looks like a water.
Typically, as lava rises through cracks in the lithosphere, it cools. And sometimes this cooling is enough for it to solidify before it erupts out of the surface. The pressure of the magma can be partially relieved by flowing into weaknesses in the surface layers of rock, creating what are called intrusions, without violent volcanic eruptions. When it does reach the surface, it quickly cools and stabilizes, whereas lava that is more liquid and remains liquid at lower temperatures flows
like
much further and much faster. This causes more destruction more quickly and across a much greater area. When this type of eruption occurs at a single volcano, such as from the Oldonyo Lengai volcano, it is highly destructive. Concerningly, a similarly alkaline, very liquid lava is also erupting from Mount Nyiragongo, 750 kilometers away in the Democratic Republic of Congo, in the entirely separate western fault of the rift system. We still do not fully understand the properties of this magma plume. The rising column of hot molten rock that is pushing upwards and causing the African continent to move and crack.
Looks kind of cool.
If it is unusually liquid, as the eruptions in Tanzania and the Democratic Republic of Congo suggest it could be, it will behave very differently to lava flows seen elsewhere in the world. It will be much more likely to break through to the surface, and it will quite simply just keep on flowing. If the underlying pressure continues to build and the rift fault still refuses to spread apart, vast lava flows of this type could scorch and cover large areas of East Africa, turning them into wastelands of barren black rock. The effects would be felt across the entire planet if the East African rift system develops into what geologists call a large igneous province, or LIP. Enormous outpourings of lava onto the Earth's surface. They occur when mantle plumes drive the formation of divergent fault systems, the very conditions we suspect are creating the East African rift. Unlike seafloor spreading, which is a slow and steady continuous process, LIP events are episodic, occurring in bursts over much shorter periods of time. Because they release enormous amounts of gases into the atmosphere, they are associated with major climate shifts in the Earth's geological record. LIP events are so extreme, they've been shown to correlate precisely with all the mass extinctions over the last 260 million years. That, of course, is a worst-case scenario, but lava flows, even on a much smaller scale, would still have dire consequences. The East African Rift System covers an area more than 5 million kilometers squared and is home to over 120 million people. Locally, this would spell disaster, forcing people to flee their homes and destroying agriculture. If this should occur at the same time that the entire planet suffers a downturn in food production as a volcanic winter sets in, there would be starvation on an unprecedented scale, not just in Africa, but globally.
It's crazy.
Of course, our saving grace here is just how slow these changes are likely to be.
We're gonna need Mr. Beast for
The
that.
EARS is opening at a rate of just 6 or 7 millimeters per year. So we're talking millions, if not tens of millions of years before anything like this would likely come into effect. These things are happening, but they're happening on geological timescales.
I mean, yeah, millions of years.
Not human ones. As the earthquakes and volcanic eruptions continue, scientists will
Some
also
aliens will
continue
have
to
to
monitor
deal with
the
it.
movements of the land surrounding the beautiful rift valleys and mountains of Africa, hoping to detect signs of what is happening under the surface. Because the pressure is building and something has to give. You get the feeling that whatever the next chapter of Earth's history will be, the reshaping of this majestic continent is slowly but surely underway and will redefine the very face of planet Earth. Whatever happens in the future, the shape of the African continent will look very different one day. If you think this video earned your subscription, please go ahead and hit that subscribe button and join us.
I think
here at
every
Astrum
continent
Earth
will look
for plenty
different,
more
right?
Amazing videos about our
Not just
continent.
Africa. Hey, shout out to Africa.